Welcome to the Deep Dive. Today, we're hitting the road, charting a course for the future of electric vehicles.
How exciting.
And no, we're not talking about which EV has the coolest gadgets or the cheapest charger.
No.
We're going deeper.
Way deeper.
We've got research from experts who are basically trying to figure out how to build the charging networks of tomorrow. And they're not just thinking about plugging in your car, they're thinking about entire transportation systems.
Exactly. It's about creating a world where electric vehicles can seamlessly integrate into our lives. Not just a niche option, but as the dominant mode of transportation.
Okay, so let's unpack this. You mentioned strategic planning. Why is that so critical right now? Can't we just build charging stations wherever there's space?
Well, it's not quite as simple as finding an empty parking lot and plopping down a charger.
No.
It's about understanding where those chargers will have the biggest impact. And that impact goes way beyond just convenience for EV drivers. It's about tackling some of the biggest challenges we face as a society, like climate change.
So you're saying that how we build these charging networks actually has a real impact on our efforts to reduce emissions?
Absolutely. Think about the European Union's goals. A 55% reduction in emissions for cars and a 30% reduction for trucks by 2030.
Wow.
Those are some seriously ambitious targets.
Yeah.
And to hit them, we need a massive shift towards electric transportation.
So if we want to see those emissions drop and make a real difference, we can't just randomly build charging stations. We need a plan, right?
You got it.
Yeah.
That's where strategic planning comes in. And it's not just about where we build, it's also about how much we invest. The European EV Charging Infrastructure Master Plan estimates a hefty price tag. We're talking billions of euros annually until 2030, just for charging infrastructure, grid upgrades, and renewable energy integration.
Wow. That's a lot of money. But it sounds like just throwing money at the problem and building more charging stations isn't going to cut it.
Exactly.
Where?
We need to be smart about how we spend those billions and make sure every charger counts.
Right.
We need to build in the right places at the right time and in a way that supports the entire network.
Okay.
It's about creating a system that's efficient, reliable, and can keep pace with the rapid growth of the EV market.
This brings us to a concept the research dives into: deep uncertainties. What does that even mean in the context of EVs?
Think of it like this. Imagine trying to plan a road trip when you don't even know what kind of car you'll be driving, how much gas will cost, or even where the roads will be in a few years.
Oh my goodness.
That's the kind of challenge we're facing with EV charging infrastructure.
So you're saying it's like trying to plan a road trip when you don't even know what kind of car you'll be driving. That sounds like a nightmare. What are some of these deep uncertainties that make planning so tricky?
Well, for starters, charging technology is evolving at lightning speed. Today, it's all about fast chargers and megawatt charging. But tomorrow, who knows? We might have dynamic charging on electric road systems or even widespread battery swapping. Trying to predict how these innovations will shape charging behavior is like trying to predict the weather a year in advance.
Right.
It's like trying to hit a moving target.
So how do you plan for a future you can't even predict?
That's the million-dollar question.
Yeah.
And it gets even trickier when you consider things like grid capacity and real estate limitations. These are essential for supporting charging infrastructure, but they're not evenly distributed and can be incredibly expensive to acquire, especially in high-demand areas.
Right. We can't just assume we'll have unlimited power and space to build wherever we want. What else adds to this complexity?
Then there's the elephant in the room. Our existing refueling infrastructure. It was designed for gas-powered vehicles, not EVs. And these locations are often in the wrong places for EV charging needs. Trying to adapt them is like trying to fit a square peg in a round hole. It's a huge constraint on where and how we can build charging stations.
So we're basically stuck with a bunch of gas station dinosaurs that aren't ready for the EV revolution. What a headache. Anything else adding to the complexity?
Oh, there's more. We can't forget about the wild west of government policies, regulations, and the fierce competition between charging providers. These factors add even more unpredictability to the planning process.
Right.
So many factors.
So many.
That we can't predict.
It sounds like we need a whole new approach if we're going to deal with all these deep uncertainties. Is that where this route-based analysis comes in?
You got it. The research suggests that focusing on routes, rather than just traffic flow, is the key to unlocking the future of EV charging.
Now that sounds intriguing, but isn't mapping out traffic flow enough? You'd think the busiest roads would need the most chargers, right?
Not necessarily. Traffic flow doesn't always equal charging demand. It's more nuanced than that. The study uses a really interesting example of a 40-ton truck To illustrate this point,
Okay, I'm hooked. Give me the breakdown.
picture this. You have a highway with a single charging station. 3 trucks pass by. A 20-ton truck, a 30-ton truck, and a 40-ton truck. You might assume all 3 would need to charge. But here's the catch. Only the 40-ton truck actually stops.
Wait, what? Why wouldn't they all need to charge?
Well, the 20-ton truck has enough range to complete its route without charging. It simply doesn't need to stop. And the 30-ton truck, it can't even reach the charging station with its current battery capacity. The network doesn't support its electrification needs.
That's so counterintuitive. You'd think traffic flow would be the key factor, but it's all about understanding those specific routes and vehicle needs.
You're absolutely right. It's about looking at the whole picture and understanding the energy demands of different roads and vehicle types.
So how do we take all this information and actually build a charging network that works? Is that where these network effects come into play?
That's a great segue. Network effects are all about understanding how the system behaves as a whole. It's the idea that adding or removing a single charging station can create ripple effects that impact the performance of other stations in the network.
So it's like a domino effect. Give me an example.
Imagine adding a single charging station in a strategic location. This seemingly small change can suddenly enable entirely new routes to go electric.
That's amazing. More EVs on the road, less pollution. But wouldn't that increase competition for the other stations?
Not necessarily. The increased EV traffic generated by that single well-placed station can actually boost demand at other stations in the network.
Wow.
It can also attract customers away from competitor stations.
Wait, so adding a station can actually help the other stations? That's wild. Network effects are pretty mind-blowing.
They really are. And understanding these network effects is crucial for strategic planning. By carefully considering these ripple effects, we can design a charging network that's not only robust, but also incredibly efficient.
Okay, I'm officially blown away by all these interconnected factors. But how do we actually put these concepts into practice? Is there a tool or system that can help us make sense of all this?
There is. And this is where things get really exciting. The researchers developed a Spatial Decision Support System, or SDSS for short. It's like a super-powered planning tool that takes all these complex factors, the deep uncertainties, the routes, the network effects, and helps planners make smarter decisions about where to build charging infrastructure.
Okay.
Smarter decisions.
Okay, I am so ready for a test drive of this SDSS Tell Me Everything.
This SDSS is like having a crystal ball for EV charging infrastructure.
Ooh.
It lets planners simulate different scenarios, evaluate potential station locations, and even optimize the entire network for maximum effectiveness.
I'm grabbing my virtual hard hat and safety goggles. Let's take this SDSS for a spin. What kind of scenarios can we test out with this thing?
Imagine this. You want to see how the charging network would perform if a new megawatt charging technology takes off? Or maybe you want to test the impact of different EV adoption rates.
Yeah.
The SDSS lets you play out all these what-if scenarios
Okay.
and see the results without having to build anything in the real world.
So it's like a risk-free sandbox for EV charging planning. You can experiment with different variables and see the impact on the network before you commit any real resources. That's pretty genius. But how does it help you actually choose where to put those chargers? It can't just be randomly placing them on a map, right?
No way. The SDSS uses a system called Multi-Criteria Evaluation, or MCE, to rank potential charging station locations.
Okay.
Think of it like a superpowered algorithm
Yeah.
that considers a ton of factors,
Yeah.
not just proximity to highways or traffic flow.
Okay. That sounds intriguing. What kind of factors are we talking about? Spill the tea.
Well, first off, it looks at things like proximity to truck stops and services.
Right.
Remember, we want to make charging as convenient as possible for truck drivers, especially those on long hauls. They need to be able to fuel up, grab a bite, and rest while their trucks are charging.
That makes sense. We've got to cater to the needs of those long-haul heroes. What else does the SDSS consider?
It also looks at the cost of connecting to the grid.
Uh-huh.
Remember we talked about grid capacity being a potential bottleneck?
Yeah.
Well, getting that electricity from the power plant to the charging station can get really expensive, especially if you have to upgrade the grid infrastructure along the way.
Right. We can't just assume that there's unlimited power available everywhere we want to build a charger.
Yeah.
So the SDSS helps us find those sweet spots where the grid connection costs are reasonable. What else?
Of course, it factors in the potential charging demand at each location,
Right.
taking into account those mind-blowing network effects we discussed earlier.
Yeah.
Remember, a single, well-placed charger can create a ripple effect, increasing demand at other stations in the network.
Right.
The SDSS helps us find those strategic locations where we can maximize those positive network effects.
So it's not just about finding a spot with high demand, it's about finding a spot where a charger can actually boost the entire network. This is getting seriously strategic. I'm impressed.
And it doesn't stop there.
Yeah.
The SDSS even factors in the competitive landscape, where those other charging companies are setting up shop.
Right.
We want to make sure we're not just building where the demand is, but also where we can actually compete effectively and attract customers.
So it's like a game of EV charging chess. You've got to anticipate your opponent's moves and position yourself for success. What else does this super-powered algorithm take into account?
It even considers the likelihood of getting government subsidies.
Wow.
There are a lot of financial incentives out there to encourage the deployment of charging infrastructure.
Right.
And the SDSS helps planners tap into those funding opportunities and make the most of those government programs.
Wow, this SDSS is like a one-stop shop for EV charging planning. It considers everything.
Right.
But with all these factors swirling around, how does it actually make a decision? How does it pick the winners?
That's where the optimization magic happens. The SDSS crunches all this data, the deep uncertainties, the routes, the network effects, the costs, the competition, the subsidies, and spits out a prioritized list of locations that are most likely to maximize those key performance indicators, or KPIs that we talked about earlier.
So it's like having a team of expert analysts working around the clock to find those prime locations that'll make the biggest impact. This is incredibly impressive. But let's bring this down to earth for a minute. How is this kind of planning actually being used in the real world? Give me some tangible examples.
One great example is the Regional Electrification Pilots, or REPs. These are initiatives that are testing out different approaches to electrifying transportation in specific regions.
Okay.
The SDSS is being used by organizations like the Swedish Energy Agency to help them decide which charging projects to fund.
So it's helping governments make smart investments and ensure that those precious euros are being spent wisely on the most promising EV charging projects. That's awesome. What other real-world applications are out there?
It's also being used to make sure government subsidies for charging infrastructure are having the intended effect. Remember all those incentives we talked about?
Yeah.
Well, the SDSS helps ensure that those subsidies are actually being used to build the most effective charging network possible, not just random chargers scattered across the landscape.
That's smart. Get the most bang for your buck. It's all about making those taxpayer dollars work as hard as possible to build a network that actually supports the transition to electric vehicles. Are there any other examples of the SDSS in action?
Absolutely. It's proving to be a valuable tool for continuous monitoring of those EV charging infrastructure rollouts.
Okay.
It helps track progress, identify areas where things are lagging behind, and pinpoint those high-priority areas that need attention. It's like having a bird's-eye view of the entire charging network and being able to see where the gaps are.
So we can see where those charging deserts are and prioritize investment in those areas to make sure everyone has access to reliable charging, no matter where they live or travel. That's fantastic. But let's shift gears for a moment and talk about what this all means for our listeners. Why should they care about this strategic planning stuff? How does it impact their lives?
That's a great question.
Yeah.
This isn't just about abstract planning concepts or fancy algorithms. It has very real implications for everyone, especially those who are considering making the switch to an electric vehicle. Imagine planning a road trip not just based on where you want to go, but on a network that guarantees you can charge your EV along the way, no matter how far you drive.
That would be amazing.
Right.
That would definitely take the range anxiety out of EV road trips. No more worrying about getting stranded with a dead battery in the middle of nowhere. I'm starting to see how this strategic planning stuff can really make a difference. But what about the bigger picture? What does this mean for society as a whole?
As this kind of strategic planning becomes more widespread, it's going to play a huge role in accelerating the adoption of electric vehicles. And that's critical if we want to achieve those ambitious climate goals we talked about earlier,
Right.
and transition to a more sustainable transportation future.
So it's not just about making life easier for EV drivers. It's about creating a cleaner, healthier planet for everyone. I'm definitely on board with that.
It really is about more than just infrastructure.
Right.
It's creating a whole new ecosystem for transportation.
Yeah, we've been talking about algorithms and data and network effects, but ultimately it's about people. It's about creating a system that's user-friendly, accessible, and meets the needs of real people.
Right. It's about weaving together technology and human behavior in a way that supports the mass adoption of electric vehicles and makes them a truly viable option for everyone.
Exactly. And as we've seen, that's no small feat. it requires a whole new way of thinking about transportation planning.
It does.
What's fascinating here is that we're not just talking about building charging stations.
No.
We're talking about building a future where electric vehicles are the norm.
Yeah,
And that future has the potential to be incredibly exciting.
it does.
Think about it: cleaner air, quieter cities, and a reduced reliance on fossil fuels.
Absolutely.
It's exciting.
Imagine a world where EV charging is as ubiquitous as gas stations are today, where range anxiety becomes a distant memory and long road trips in an electric vehicle are not only possible, but enjoyable.
That's the dream.
It is.
That's a future I can definitely get behind. But it's not going to happen overnight.
No,
It requires careful planning, strategic investment, and a commitment to collaboration.
absolutely. We have to work together.
Yeah, if we connect this to the bigger picture, this is about more than just cars. It's about creating a more sustainable and resilient transportation system for generations to come.
For sure.
So what does all this mean for you, the listener?
That's a great question.
It means that the decisions we make today about EV charging infrastructure will have a ripple effect for years to come.
Absolutely. Every decision counts.
This raises an important question for all of us. As we transition to this new era of electric mobility, what role will we play in shaping its trajectory?
What role will we play?
Will we embrace the challenges and opportunities it presents? Or will we be left behind? The future of transportation is in our hands.
It really is.
So the next time you see an electric vehicle on the road, think about the complex network of planning and technology that made it possible.
And the people.
And the people.
Yeah.
And remember that the choices we make today will determine the course of electric transportation for generations to come.
Until next time, keep exploring.
Keep questioning.
Keep diving deep.